Okay, so now this is the second video. So in the first video of the process of the ArcGIS catchment finding, we had our coordinates, we selected digital elevation model, and we made digital elevation model. Third step is to open the ArcGIS and then enter the digital elevation model and create the shapefile. So let's start that. First of all, we need to open the ArcGIS software. So click on it and open that software. So let us wait for it. So if you see the software is now open, now close this window and click on File, New. In the new, you can just now select the folder where you want to save it. So click on this. Select the folder where you want to save it. So I have just selected this folder. This is important step, remember. So I have named the folder ArcGIS Catchment. This was already named, so you guys can just do it right now. Okay. Then the next step is create a new file geodatabase. And it's created. Now click on it and add. Done. Your folder is selected. Okay. Now if I open the window here, and in the window, if you click on the catalog, so do you see this catalog? This is the folder that I created, ArcGIS Catchment, and this is the geodatabase that I created. You guys can just click on it and right click and make it default. I have already made it default. You guys can make it default if it's not in your case, right? So yet your settings can be automatically saved there. Okay, now the third step is take the digital elevation model that you created and drag it to the software. And yes, so this is the digital elevation model of our location that we selected. Which location? This location, this region. This is how it looks like in a digital elevation model form. So this black and white represent the elevation and depression and everything like that. Okay, now once you have the whole region, you need to locate the exact point. Like for example, if this is the dam, if this is the dam, this is the dam site, so you need to locate the exact dam, right? You need to locate the exact point for which you're trying to find the catchment area. So we know the coordinates of that point, so let us locate them using the coordinates. First of all, let me enter a point here. So for that, I will click on the folder where I want to save the settings, and then I will right click, new. Okay, sorry, I clicked on the other thing. Select the folder, not the geodatabase file, the folder. Right click, new, select the shapefile. Now name it, I will name it inlet. Select point, edit, click on edit, go to geographic coordinate system, go to the world, go and select WGS 1984, okay, and then okay. Done. Your inlet shapefile is created. Now make it here, create it here, draw it here. How you are going to draw it here? Click on editor, start editing, wait for it, keep waiting. Okay, done. Now click on the create features. Once you click on the create features, your create features tab is open, but it is hidden behind the catalog. So let me remove this catalog. Come on. Yeah, just take it somewhere there. I think oh, okay, let me close this one and just place the catalog here like this, and create features is this. Okay, in the create feature, I created this inlet. Click on it, it is a point, so click on the point and place the point anywhere randomly. So let's suppose this is a point. Now I need to place it exactly at the coordinate that I have. So how can we do that? Right click, absolute XY. In the absolute XY, just click on the arrow, degree, minute, seconds, and here we go. We can enter our coordinates. What are the coordinates? 34 18 18 north, 71 24 04 east. So 17 24 04 east and 34 18 18 north. Now enter, click on enter, and do you see this point? This is the exact location. So this is wrong. So what are we going to do now is editor, save edits, then editor, stop editing, then again editor, start editing. Then this is the wrong point. So click on it, right click, delete, editor, save edits, editor, stop editing. So this is the correct point and that is deleted. Okay. Now the next step is, if you think that this window is too big, you guys can still crop it or cut it or clip it. If you guys don't want to do this, you guys can skip this step, but I would recommend to do this step because this can be useful if you want to know more about the software ArcGIS. So let us do this step. This is a small step. So how are we going to do that? Like for example, once you locate your inlet point here, you know somehow that your catchment area is going to be somewhat like this or maybe somewhat like this. So you know that some part is extra, so you guys can just estimate it and crop it. How you can crop it, let me show you. Go to the ArcGIS catchment, the folder where you want to save the settings. Right click, new, shapefile, name it rectangle. Then instead of point, select polygon, edit, and do the same step again. Geographic coordinate system, world, WGS 1984. Okay. Now you're gonna select OK. Now again, you know the drill. What you're gonna do? Editor, start editing. Create features, rectangle. Select rectangle instead of inlet. Polygon or in rectangle. Select the exact rectangle. Now what you're gonna do? Make a rectangle. So I am estimating that my catchment area will be somewhat like this, and just drag it like this and done. So this is the rectangle that I have created. Now editor, save edits, editor, stop edits, done. Now the next step is we need to crop it or remove the background and just leave this part. So how are we going to do it? In order to do it, Windows, search, click on the search. Once you click on the search, so okay, I can just bring the search here. In the search, enter clip. Once you click on the clip, search it, select the third one. Once you select the third one, input raster. The input is going to be what? The input is the whole image that you have. What is the whole image? The whole digital elevation model. So it is N34E071. This, find it. This is that input. The software already knows you have only one input, so enter it. And this is the correct input. This is the whole image which you want to crop. So the image that you want to crop, you have entered it here. So let us wait for it to process. Now do you see the time that it is taking for the processing? This is why we need to reduce the stress for the software by cropping or clipping it. Now the output extent. What is the output? The output is rectangle, no? Because the rectangle is the exact shape, the small shape that I want instead of the whole bigger rectangle. So we want the smaller rectangle. So select the smaller rectangle and then OK. Now wait for the clip to perform. It is still, when it is completed, it will appear here. So let us see. Let us wait for it. So let me pause the recording because it will take a little bit of time. Okay, so the clip have been performed and you see this is a new file that have been created, that is a clip file. Now if I uncheck this, so this will disappear. So do you see now 1 2 3 gone? So only, and if I uncheck the rectangle, so only this is now available. So this means the rectangle shaped area is only available for us, and this is the location that we located, right? So now our catchment area is going to be here. Now the software will be feeling less stress and it will take less time to do the process instead of the previous one. Okay, now you guys can just skip this step and do it directly, right? Okay, so I think this is this enough? The next step is use fill tool, use the direction. Okay, let's to use the next tool as well. The next step is now cross this. The next step is click on the arc toolbox, open it. In the arc toolbox, go to spatial analysis tool. In this, go to hydrology. In the hydrology, click on the fill. Now double click on the fill. Input raster. Input is going to be what? The new file, that is the arc v3 clip. So click arc v3 clip, select it, and nothing is needed for the output or z limit. Just leave it and OK, and let the fill to be performed. So the fill is still being performed and it will take a little bit of time. So let me pause the video again, and here we go. The clip have been performed. Oh, sorry, the fill have been performed. The next step is the flow direction. So for the flow direction, Let's click on it. Select the input raster to be the fill. Then the fill is the updated one. So click on the fill and don't do any changes in the other one. Okay. And now wait for the flow direction and let us wait. Okay. So this is the flow direction that have been obtained now. So if you zoom it, it will be clear. So of course these colors and everything represents the exact flow direction of the water. Now after the flow direction, after you got the flow direction, the next step is where this water is going now and being collected. So because once you know that the flow direction is, like, let's suppose once you obtain that the flow direction is this one, the other says the flow direction is this one, this one, this one, so you know that the water is being collected somewhere. So here you have this much water, there you have this much water, you can just estimate that. So this is how the flow direction is important. Now the next step is the flow accumulation. The accumulation means where it is being accumulated, just like this is accumulated here, this is accumulated here. So how much water is accumulated where? For that we will continue from the next video. For this video I think that's enough, so thank you very much.